When people hear that Arabica coffee is struggling, they usually land on one of two answers: move the farms higher up the mountain where it's cooler, or switch to Robusta, which handles the heat better. Both answers are possible, but neither is the right one. Mountains end, and the land above existing farms is often too steep, already protected, or impossible to connect to a road or a mill. Robusta is not a different version of Arabica under warmer conditions. It is a separate species, with its own chemistry, its own flavour, and a different position in the market. That gap between the obvious fix and the reality is already showing up in what reaches your cup. Origins that used to be reliable are becoming seasonal. The Arabica you are drinking today may come from a farm that is one bad harvest away from changing variety, changing crop, or stopping altogether. Most coffee drinkers do not see that. They just see the bag. When people describe coffee as sweet, floral, fruity, clean, or complex, they are usually drinking Arabica. It is also the species that dominates specialty coffee, most washed Highland coffees, and many of the origins that roasters use to build their reputation. Arabica evolved as an understory plant in the highland forests of Ethiopia. It does not behave like a crop that was designed for exposed, hot, or lowland plantations. It prefers mild conditions, steady moisture, and enough shade or cloud cover to reduce stress. A rough comfort zone for Arabica is around 18 to 22 degrees Celsius for mean annual temperature, with some sources citing a workable range as wide as 15 to 24 degrees, depending on variety, shade, and management. Rainfall requirements sit at around 1,500 to 2,500 millimeters per year, ideally spread across a 9-month growing period, with a 3-month dry season to help trigger flowering. Most commercial Arabica farms sit somewhere between 1,000 and 2,000 meters above sea level, though lower elevations around 600 meters are workable in subtropical regions further from the equator where the ambient climate is cooler. High-grown coffee is often assumed to be better coffee. Strictly speaking, altitude itself is not magic. A coffee tree does not know how many meters it is above the sea. What it experiences is temperature, rainfall, sunlight, soil, wind, and disease pressure. Cooler temperatures slow the development of the coffee cherry. Slower ripening can give the seed more time to build the sugars, acids, and aromatic precursors that later become flavored during roasting. The same cooling can also reduce some pest or disease pressure depending on the region. So when people say Arabica likes altitude, what they often mean is that Arabica likes the climate altitude creates. When the climate starts moving, altitude stops being a reliable proxy for any of it. Coffee grows in the tropics. The coffee belt is not a neat strip of usable farmland. It is a broken pattern of highlands and valleys, rainfall zones and dry corridors, forests, roads, and farms. From a distance, the tropics look like they have plenty of land available for coffee. Most of it is unusable for Arabica. The land is too hot, or too exposed, or too remote to connect to a mill or an export route. Some of it's already farmed, or already inhabited, or legally protected. The part that remains is smaller than the map suggests. Arabica needs a narrow combination of conditions to work. Enough warmth to grow, but not so much that the plant becomes stressed. Enough rain to flower and fill the fruit, but not so much that disease and erosion become constant problems. A dry period helps trigger flowering and makes harvesting more predictable. Too much irregular rain scatters the flowering across the year, which makes the crop much harder to pick and process consistently. Temperature is the easiest variable to measure, but a farm can sit at the right temperature and still fail because the soil is wrong. Arabica needs nutrient-rich, slightly acidic, well-drained soil, the kind that forms naturally on volcanic slopes and in highland forest environments. That is one reason so many of the world's best-known Arabica origins sit on or near old volcanic geology. Where that soil does not exist, it can sometimes be managed, but not cheaply and not everywhere. A farm can also fail because the water supply becomes unreliable, or because there's no road to get the harvest out. Climatic suitability and agricultural viability are not the same thing. A place can satisfy a computer model and still be unusable for a farmer. The right soil, a nearby mill, a buyer, and a secure land title all have to exist before the investment makes sense. The common answer to warming coffee regions is altitude migration. In a warmer world, the suitable Arabica zone shifts upwards. In principle, that part is true. When lower slopes become too hot, higher slopes may become more suitable. Some regions near the equator, especially those with large areas of highland and reliable rainfall, may retain or even gain suitable land in particular zones. Ethiopia, Colombia, Kenya, and parts of the Andes are often discussed this way because they have high elevations, established farming communities, and the process of the infrastructure already in place. Even when suitable land exists higher up, it may not belong to the farmers who are losing suitability lower down. Around 125 million people depend on coffee farming globally, and the vast majority of them are smallholders working less than 5 hectares. A smallholder cannot just walk uphill and take a new plot. Moving coffee is not like moving a plant pot across a patio. It can mean buying and clearing new land, planting new trees, waiting years for production, learning a different microclimate, and surviving several harvests with less income. Coffee trees are slower investments. A new Arabica planting typically takes 3 to 4 years to bear first fruit, and 5 years or more before it produces commercially useful volumes. Peat production can take a decade or more to arrive. If a farmer replaces trees, changes variety, or moves location, the cost arrives long before the payoff. For most smallholders, that financial gap is the real barrier to adaptation. Suitability models can identify which regions gain viable growing conditions as temperatures shift. What they cannot model is whether those regions can become functioning coffee economies. A climatically suitable hillside in a new region is not a coffee farm. The model can find the right temperature and rainfall. It cannot find the mills, the roads, the buyers, the land title, or the farmers willing to wait a decade for trees that pay off. The future of Arabica will be uneven because of that gap. Some farms will adapt successfully. Some will produce different coffee at lower quality before they lose value entirely. Some will shift to other crops, and some may gain real opportunity, but only if institutions, farmers, buyers, and nurseries all move in the same direction at the same time. Global coffee production figures can look reassuring. The world produces hundreds of millions of bags a year, and consumption, while growing, has not yet outpaced supply. On paper, there is enough coffee. The problem is that the headline total combines Arabica and Robusta. When Arabica production falls under weather pressure, Robusta often picks up the slack, keeping the overall numbers stable. The headline total can look fine, while the Arabica share underneath it is shrinking. When numbers are bad, it is not coffee in general that runs short. It is Arabica specifically, and that shows up in prices and available stocks long before it shows up in the headline. For farms that stay in Arabica, shade management is one of the most actively researched adaptation tools. Shade trees lower the temperature at canopy level by around 2 to 4 degrees Celsius and help retain soil moisture. Managed at the right density, somewhere between 30 and 60% canopy cover, they can also reduce some disease pressure, though dense shade trees raise humidity and can increase rust risk rather than reduce it. A farm that sits at the edge of what Arabica can tolerate on paper can still produce good coffee if the canopy is managed well. It does not solve the geography problem, but it buys time for farms that would otherwise be pushed out altogether. Robusta is often treated as the obvious escape route. Arabica struggles with heat. Robusta tolerates more of it, so grow more Robusta. There is truth in that. Robusta, more accurately, Coffea califorà, is generally tougher. It handles warmer conditions, lower altitudes, higher pest and disease pressure, and in many places produces heavier yields. It is central to instant coffee, many espresso blends, and a growing amount of mainstream coffee production. Fine califorà is no longer a fringe idea. Producers in Brazil, India, Uganda, Indonesia, and Vietnam are all raising standards across harvested, processing, and drying, and some roasters are beginning to use it not as a cheap filler, but as a deliberate flavour and body component. For specialty coffee, a roaster can build a good product around califorà, but it will not taste like a washed Ethiopian Arabica, a Colombian Highland Loss, or a bright Central American bourbon. If Arabica is too fragile, the answer is to create better Arabica. The goal is trees that are more productive, more heat tolerant, more disease resistant, and capable of holding cup quality under stress. Coffee leaf rust is the most pressing disease target. It is a fungal pathogen that attacks the leaves and spreads rapidly in warmer, wetter conditions. Breeders, nurseries, and national coffee institutes are all working on it. Farmers now use rust-resistant varieties, introgressed varieties with genetics from other coffee species, and newer F1 hybrids designed to combine productivity, cup quality, and resilience. World Coffee Research's hybrid trials have reported significant yield gains while maintaining specialty-grade cup scores. Traditional variety development still takes 25 to 30 years. Even F1 hybrid development typically takes 10 to 20 years before a variety reaches farmers at scale, and a variety that works well in one country may not perform the same way in another. Breeding can widen the window, but it cannot make Arabica independent of climate, soil, water, labour, and money. The coffee genus contains around 130 described species, and most of them are neither Arabica nor Robusta. Some are being studied for traits that could matter in a warmer world. Stenophylla is the best-known recent example. It is a wild species from West Africa that researchers found can tolerate much warmer conditions than Arabica, while still producing a flavour profile closer to Arabica than Robusta. Recent reclassification work has also found that what was previously counted as a single Liberica species is several distinct species with different climate tolerances, which suggests the genus contains more useful variation than previously understood. A species can be promising in research and still be nowhere near becoming a global commodity, though. The coffee world cannot replace tens of millions of bags of Arabica by discovering a rare species and planting it everywhere. These species may become breeding resources or niche crops or regional solutions. For the near future, the Arabica problem remains an Arabica problem. When the coffee is sold on the strength of where it comes from, what variety it is, or how it was processed, that promise depends on the stability of the place behind it. A warmer region may still produce coffee, but the cup changes. Cherries ripen faster, which compresses the development time that builds sweetness and acidity. Disease pressure rises, harvest timing becomes harder to predict, and the processing becomes harder to control if rain arrives at the wrong point. Farmers may need more shade, more irrigation, and more labour-intensive processing just to hold the same standard. Some can afford that, many cannot. The consumer rarely sees any of that. They see the bag get more expensive, the flavour become less consistent, or the origin disappear from a roaster's menu. For decades, specialty coffee culture trained people to treat Arabica as the quality species and Robusta as a cheap one. That framing is already too simple and will become less useful still. Some Arabica will be ordinary, some Califora will be excellent. Some of the new hybrids will taste familiar and some will not. And the ones that work best may not come from the places that produced the best coffee before. Understanding the geography changes how the coffee world looks from the outside. When you see a price spike, it is worth asking whether this is a weather event or something the market is slowly pricing in. When an origin disappears from a roaster's menu, it may be a sourcing decision, or it may be that the farm can no longer reliably produce what the roaster needs. When a new variety or a new species gets attention, the question is whether it can reach the scale and consistency that a commercial supply chain needs, not just whether it tastes good in a trial. The geography was always the constraint. Altitude was just the way Arabica hid it.